This is a video about increasing and decreasing functions and the first derivative test. First thing I'm going to do is I'm going to take a look at this function by itself and kind of think about it. I know that it's a parabola. I know it goes down 4, has roots at -2 and 2. It looks like this. So the idea behind the first derivative test is to identify which parts of the function are increasing and which parts of the function are decreasing. And if you know what the function looks like, it actually is pretty easy to do. We know that this function would have a decreasing interval from -infinity to 0 and an increasing interval from 0 to infinity. Now, using the first derivative test, I'm going to show you why that works. Okay, so we'll come back to those two answers right there. So let's take the first derivative. This one's a pretty easy one. You know, depending on how complicated it is, that's probably the hardest part in some cases. So the f prime of x is power rule just 2x. So what does that look like? So slope of 2, I know that's not really a great graph, might as well just fix it. I can do better. So something like that. So there's the derivative of that parabola. Now, what we're looking for is where is this graph positive and where is that graph negative? Now, again, we're looking at the graph, so it's super easy to just look at that and say, oh, it's 0 here, it's above the x-axis here, it's below there. Well, another way to do that is algebraically. So let's take a look at saying, when does 2x equal 0? We can divide by 2, and x is 0. So the only place in this graph where it's 0 or undefined is right there. That means everywhere else, the derivative is either positive or negative. So we're going to go and we're going to find out a number. So here's a little number line. Here's 0. We're going to find a number over here. So let's take like -5, and we'll find a number over here. Let's plug in 3. And when we look at f prime of x, at f of -5, we get -10. At f prime of 3, we get 6. So let's talk about what that means. On this interval, from 0 to positive infinity, it will match whatever the behavior is for that number. So when we plugged in 3, we got a positive number. That means all other numbers on that interval will also be positive. If we plug in -5, we get -10. And that means that any numbers on that interval are negative. So the derivative is negative here, the derivative is positive there, which means if the derivative is negative, then the function itself is decreasing. If the derivative is positive, then the function is increasing. So let's take a look at a slightly more complicated one. And again, these can get pretty complex as far as finding the derivative. So that would be step 1. Find the derivative, which is 3x squared minus 2x. We then need to find where the derivative is undefined or 0. So we're going to look for the zeros or where it's undefined. So looking at 3x squared minus 2x, I'm going to factor out an x, leave me 3x minus 2, and we know that that would be 0 at 0. We know this would be 0 at 2/3. So those are the two zeros of my derivative, which breaks that graph up so that it would have roots here and roots here. So it's either going to be positive, negative, positive, or exactly the opposite of that, negative, positive, negative. So each of these intervals, this interval could be positive or negative. This interval could be positive or negative. That interval could be positive or negative. So how do we test that? We're going to find a number on each interval. So a number on that interval, let's go with -1. Here, let's go with 1/2. And here, let's go with 1. Pretty reasonable numbers to plug in. And again, we're plugging them in to G prime. So we're going to do G prime of -1. We'll do G prime of 1/2. And we'll do G prime of 1. So if we plug those in, 1 would give me, -1. 1 would give me 1. -1 would give me 3 plus 2, which is 5. And then 1/2, I'll do that one out, 3 times 1/2 squared minus 2 times 1/2. That's 1/4, so 3/4 minus 1, -1/4. So we can therefore determine that this entire interval would be positive because when you plugged in a value there, it was positive. Here it's negative, and here it's positive. So from that, we can then write our increasing and decreasing intervals. So wherever it's positive, it's increasing. So we're going to say increasing from -infinity to that first root, which is 0. It's decreasing. I'll go with that one over here, 0 to 2/3. And it's also increasing from 2/3 to positive infinity. And that's what the first derivative test is all about.